Yeah, okay. Good evening and welcome to our last session from the class, which is called Network Systems for Music Interaction. And in this class, we worked with the server system for online performances, which we call the Sprawl system. And we started with that like last year already, but this was the first time that we really tried to have students program their own projects on the server. So that means long story short is that we have this server mixing a virtual acoustic scene, and this is actually what you're hearing already is me moving in this binaural mix with one of the tools we will use for a performance, which is this graphical user interface by Simon. And what was the challenge for us was to program the server for the individual projects, and that means that there's a lot of skills involved, so which not only relate to music or DSP programming, but also there's a lot of taking care of server stuff, running services on this Linux server. And so I'm pretty happy that we now have 4 projects which have a very individual focus each. So the first one will be on direct control for the musicians. That means everybody's able to control his or her position in space with a graphical user interface. Then we have another project, the second one, which is a processing based project. That means all the sound sources will be processed with delays, feedback delays, and this is more like a processing based project. The third project will be one where we interact by sending emojis to a server, and that will then be sonified. And project number 4 is one with audience participation. So that means that you, the audience, can control the source positions of everybody. And I'm pretty happy that we have these 4 projects in the end, because it takes a lot of learning all the different things, and that's why we're having this in a presentation between concert and workshop presentation, because to be honest, we used all the time for programming and testing our projects with the whole group. And that means that working on the musical part is the next step, which we will start today all together with the audience. I'm now handing over to project number 1, which is Simon with his position UI, and everybody will give a short introduction on their projects, and we will then use some different concepts for showcasing them. So Simon, bitte.
Okay, cool. So as mentioned before, this project is about providing a graphical user interface for every player to move their position in the virtual space. And I will share my screen to demonstrate this. And this is programmed in Python and runs on every system locally, and then it communicates with a central supercollider server through WebSockets. And to demonstrate this, we will play a short piece that is loosely based on Blotgat by Robert Stokovia, which is a graphical score, and it includes a lot of directions for movement through space. So it's well suited to use with a project like this.
Hello, hello. Okay, yeah, thank you. So that was the first project by Simon, and we are now moving to Valentin's project. And so, maybe as an explanation in between, what's happening is that everybody is responsible for starting the project on the server, uh, and that means it takes just 1 minute to make this swap. That means Simon just stopped all the processes he's using for his project, and Valentin is now busy starting. Okay, and that just happened. So I'm pretty sure we're now running Valentin's software already, and then maybe he can give an introduction.
It's my server's not yet running. Is it? Yeah. I created an implementation of a delay into this server system. So everyone has a little program in PD where he can control 4 parameters of the delay, like the delay time, the feedback, and the wetness of the effect, and also the sample lengths. And additionally, it also plays with the spatialization, so everyone is placed on a circle and with equal distance, and at some time the sources start to move in the space, also in the horizontal plane and also in the vertical plane, so that all the orbits are rotating around the listener. And yeah, we can start. But yeah,
I think we need to restart your server once
Yes.
again.
Can you kill the current one?
Yeah, I think we just need to make sure that the other stuff is not running anymore. So let me take care of that.
Okay. Now we are back. Sorry for the delay. Yeah, since it's called a delay, it's always coupled with a delay. Let's start this one.
Okay, sorry. I think we have to be so brave to stop here because I'm seeing the problem. So this is there's two servers running, and so that means we have been sending our stuff to the wrong address, so to the wrong port. Can you, Valentin? I will kill everything now, and then you can restart. Okay. Okay. Maybe we
Okay.
can now make a small check before we get started with the. Okay.
Yeah.
So yeah, sorry for this first wrong version. I think we can now start over.
Yeah, okay. Start.
Okay.
Thank you.
Yeah, thank you, and thank you everybody. So this was the delay piece with a lot of real nice noisy atmosphere, and we're now moving to the emoji project, and for this we will be totally disconnecting our own audio after. But I will restart a clean server for Lucy and Laurin to introduce their project. That's what I'm doing now. Okay, so please, yeah.
Yeah, hi. So our piece connects emojis and sound, and emojis are small pictograms that you can send in chats, as you probably all know. And our piece is based on one of the a paper that was published in 2015 by Novak and alumni. And to find out what the emotional contents of emojis are, I mean, that was the aim of this paper. And we thought we could use what they created as some kind of to create sounds with Super Collider. And basically what they did in 2015 with this analysis is they created an emoji sentiment lexicon. They called it the emoji sentiment ranking, and they drew a sentiment map of the 750 most frequently used emojis, and it's publicly available. It's a website that looks quite nice, and I saw that and I thought we could make something out of that. So maybe a little bit more about the emoji sentiments. So sentiment analysis is widely used to, for example, to find out trends or if something is not very well perceived by the public. And they used tweets from Twitter and had them, they had 1.6 million tweets, and they had them annotate, they had 38 people annotating those tweets, and by sentiment polarity, that is, if a tweet is negative, neutral, or positive. And about 4% of those annotated tweets contained emojis, and they were analyzing those, and as an outcome created the sentiment ranking map. And one of the interesting results was that most of the emojis actually have a positive sentiment value that we can see here. Each circle represents one emoji, kind of like down here, but they didn't put the emojis there. And the bigger the circle, the more emojis they had of those. And as you can see, there's a big spreading over on the right side of 0, which is 1 is the most positive emoji possible, the most positive sentiment, and -1 is the most negative. And it's clearly visible that there's more positive than negative emojis, which is why our piece got the name Positive Pixel. And we are making use of the sentiment ranking, and the way it works is that we have a Python server that is receiving messages, emoji messages from the participants, and they have this little interface which I can open up quickly. It looks like this. So they connect with a certain server IP and the server port, which is connecting to the Python server, and then they can set their name just like in a real live chat and can send those emojis that we have here. And from the Python server, those emojis are then, we get the sentiment values from this sentiment lexicon and send that to Super Collider. And in Super Collider, we make use of 4 of these values, which is the 4 I'm marking right now. And we use those to create sounds. So the overall sentiment score is mapped to the overall frequency of the sounds. And we have 4 sense definitions, which all sound a little bit different. And this, the overall sentiment is mapped to the frequency, and but we keep the frequencies in a lower range, up to 800 is the max, I think. So an emoji with a sentiment score of 1 would have the maximum possible frequency of 800. And then the negative, neutral, and positive we use to create an envelope for the amplitude of gain of the synthesizer. So we have, for example, this emoji right here, the two little hearts. They have a rather positive sentiment, as we can see here. And if we look at the envelope that is created by Super Collider, we see it looks like this. So the attack time is very short, and kind of the sustain time is also kind of short. And then the positive side of the emoji sentiment is mapped to the release time of the synth. Equal goes for all the other emojis. We have, for example, the yin yang emoji, which I can't find right now, but basically the yin yang emoji, oh, here it is. It has a very neutral score, which makes sense if you think about what yin and yang is. And that results in an envelope that looks like this. So we have a really short attack and really short release, and then this rather long sustain time. And then we have the negative emojis, which there's not a lot of, as you know, because most of the emojis have a positive sentiment. But for example, this negative one, the imp, has a high negative value, and that results in the envelope looking like this. So the sounds of the synthesizers are rather simple, but we have these envelopes, and if you listen carefully, you might be able to figure out the sentiment of a certain emoji just by listening to, just by looking at the chat and listening to the amplitude of that emoji. So I will now start the server, and people can start connecting to it. Actually, we have to disconnect the other server first.
Okay,
So,
I will stop that one,
Exactly.
and then we will be back afterwards. Okay. Yeah, thank you for the nice concept. And it's actually, yeah, as I said, we didn't have the time to really explore these new tools. So I just noticed how that it's not so easy to always find the right emoji and to watch the movie at the same time. But yeah, so that would need more rehearsal too. But I think, yeah, really worked. And thank you for the
Yeah, well,
implementation.
I couldn't fix the one thing, but yeah, it worked roughly. That's nice.
And so yeah, we're now moving to the final project of today, which is Peter with the audience control. Do you want to start your stuff now and I'm stopping the generic server, or?
Sure.
Okay, so I'm handing over and he will start his software on the server.
Okay. Hello?
Hello.
All right. Sounds good. So I will share my screen briefly to describe my project. Do you see it? So the title of my project is called Audience Control, and the idea is to put the power in the spectator's hands. And we were interested in the idea of sort of generating randomness by so these uncontrolled parameters if you guys watching want to participate. So the idea is that with this interface, this remote, you can control the spatial parameters of all of the performers currently in the Zoom session. So these, first you have to select a source here along the top, and one of these 11 sources corresponds to, one of the 11 performers. The idea is that we're keeping this anonymous because there's sort of a game attached to this to encourage participation. So you select the source, and then from here you can adjust the reverb, gain, distance, elevation, and rotation. So this sort of changes these acoustic signals in this virtual performance space that our server software creates for us. And then as our performance goes on, I think we'll be doing some jam session. You're encouraged to then organize this list of our names to submit a guess as to which source belongs to which performer. And then as well, you can visualize your results here. So I got 0 correct. So yeah.
I was just wondering, could we share the link?
Yep.
It should be shared in the. Maybe it already has been shared. No,
So
there it is. So it's now. So should we start? You let us know.
So maybe we should adjust each other's parameters a bit just to get started. I already see some requests coming in. Okay, I set everything back to normal.
Yeah, okay. Yeah, thank you for the final project of this session. And that was the first time that we played controlled by, yeah, I don't know how many people are watching and have been controlling. I will check that afterwards, but something has been changing over the time, and I've been, yeah, it was quite interesting. So, yeah, that concludes all our projects. And so, yeah, thank you to all the 4 groups, or like the 4 projects which we've presented tonight. Thank you also to all the students who participated and contributed by playing within these projects. So thank you also. And also special thanks to, as usual, Niels and Paul, who made most of this possible. So Niels as our server expert, and Paul did the streaming. I don't know, he's hidden. Maybe we will see him, maybe not. So that's everything. And I'm pretty happy that we, although this is what we called it a demonstration / concert / workshop, but it's quite nice how we could work on this one server together, and was not easy, but I think we're getting there. So as I said, there was just one project last semester. Now we have 4 projects, and we're starting to establish a way of working with this as a group. Yeah, so thank you everybody. Have a nice weekend. Have a nice summer, because I think this is the very final thing that's happening in the semester, at least for us. And see you someone after the summer, I guess. I don't know. Or we could also. I really don't know. Do we have any? Sometimes there's questions from the chat. Sometimes no. But I've. Let's not mention how many people are watching now, because they could. But is there any? Sometimes we have feedback questions. I didn't check it yet, but that's not the case, because there might be questions on the projects. Okay. So then, yeah, have a great summer. Thank you again for the projects, for participation, for making that possible, and see you soon.